first thing that we need to do here is we need to define on the inside of this what is the multiplication counting principle. And the multiplication counting principle states if there are m amount of ways to make a selection, and n ways to make a second selection, there are m times n ways to make the selections. Brandon, get up here.
I didn't want to cheat.
Cheater.
I'll go back.
Okay.
I think teacher direction trumps the unfreezing of another student. So,
I started this.
no. If there are m ways to make a selection and n ways to make a second selection, then there are m times n ways to make the selections. So, for an example, if I have 5 shirts and 3 pairs of shorts, I have 2 different selections that I'm trying to make. I have the selections of shirts I'm trying to make, and I have the selection of shorts that I'm trying to make. So the number of possible outcomes comes from 5 times 3. So there is 15 ways, 15 different outcomes, or 15 different ways for you to select 1 shirt and 1 pair of shorts. Okay, so you're just multiplying essentially the amount of choices that you have.
That's also how you figure out how many combinations Padlock can have.
All right. There are 2 specific types of ways that we can arrange things, and we're going to spend our time today talking about something called a permutation. Okay? A permutation is an arrangement of objects in a specific order. So when we're talking about permutations, order is important. So an example of this would be, I want to figure out how many different arrangements of the letters A, B, and C I can have without repeating any of the letters. So no like A, okay? So I'm using A, B, C, and I want to figure out how many different ways can I arrange these letters. So of course, we could have the arrangement of ABC.
BAC.
We could have BAC. We could have CAB. We could have BCA. We could have CBA. And we can have ACB. Okay? So these are the only options I have for using A, B, and C and writing them in different orders without repeating them. Okay? And what we need in order for us to decide permutations, because there's actually a formula for us to find permutations, but it includes something that is called in factorial. Okay? In factorial can be written, or is usually written, in notation that looks like this. Okay? It's an exclamation point. And in factorial means that it is the product of integers for n to 1. Okay, so n can be anything. I can have any number be a factorial. So for example, down here I have 6 factorial. That means that I'm going to be multiplying all the numbers between n, and in this case n is 6. I'm going to be multiplying all the numbers between n and 1 together. So I have 6, and then all the numbers between 6 and 1 would be 6, 5, 4, 3, 2, and 1. Okay? So 6 factorial is taking and multiplying these all together. Okay? 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. Times 1, of course, is itself. So 6 factorial would equal 720.
You're so smart.
Okay? Now we use factorials when we are trying to figure out permutations. Okay? And permutations, when you see them most of the time, are going to look like this. Okay? You have 2 subscript numbers here, and then this is a P. The P stands for permutation. Okay? The N here stands for the number of objects. And the R stands for how many are arranged at a time. And if you see something that looks like this, it can be performed using a formula that looks like this. N factorial all over n minus r factorial. Okay, so n is on the left, r is on the right. The larger number will always be on the left-hand side. So what this looks like then, if this is my example, I'm going to use this formula. Again, my n is the number on the left side, so I'm going to go 8 factorial all over 8 minus 2 factorial. And just to show you how this works, 8 factorial again is all the numbers from 8 to 1 multiplied together. So I'm just going to write this out to show you where this comes from. So here's all the numbers between 8 and 1, all multiplied out. And then here, 8 minus 2, that gives me 6. So then I'm going to write 6 factorial, so 6, and then all the numbers between 6 and 1. So what's going to happen here is you notice that you have a 6 on the top and the bottom. Those are going to cross off. The 5s are going to cross off. The 4s, the 3s, the 2s, the 1s.
Whoa!
So all you're left with is 8 times 7. So in this particular permutation, there are 56 possible combinations. Okay? So, I want you to go ahead and start 7 permutation 4.